So, we just got done talking about the distribution for the sample means. And we actually created a whole distribution just so we could really understand what that was talking about, where we were taking like a sample, we did so many pumpkins at a time and found the mean and found the probability of every possible mean showing up. That was our probability distribution. We are talking about now a sample proportion. So, for instance, you don't need to write this part down. Suppose I want to determine the number of households in Monroe City that would favor a tax increase to fund a new baseball field. Okay, ideally, I would want to talk to every household, but often that's not possible. You know, Monroe City, it's not like it's a huge town, so maybe we could talk to every household, but if you were to go to Kansas City, would it be feasible to say you were going to talk to every household? No, absolutely not. So we need a way to estimate what people think. And so that's what comes in when I talk about a point estimate. If I have a random sample of size n from a population, and either the individual does or does not have a characteristic, so they favor this or they do not favor it, then the sample proportion, we call that p hat, and it's just exactly what you think. X over n. X is the number of individuals with characteristic. N is the number in our sample. P hat estimates the true population proportion. So it would be like saying I surveyed 100 households and 75 of them were in favor. So my P hat would just be 75 over 100. Okay, really not anything new. We have found things like this before. But I am going to start throwing p hats in here, so you might at least jot that definition down so you know what it means when you see it. Okay, so let's do a problem. So a poll in 2008 found that 1,745 registered voters nationwide, they were asked whether they approved of the way George W. Bush was handling the economy. 349 responded yes. Obtain a point estimate for the proportion of registered voters who approve of the way George W. Bush is handling the economy. So I'm asking for the point estimate, the p hat. Even if I hadn't taught you anything today, what would you think you should do here?
349 over 17.
And you would be correct. So if we divide that, you get 0.2. So that is our point estimate. Based on the sample, we see about 20% of the voters approve.
And, okay, so our p hat, that's all it is. Seems easy enough.
Good. Okay, so the next one. I'm going to show you some graphs here, so we're not necessarily writing out, we're trying to make some conclusions. According to a poll, 42% of registered voters believe the president should be impeached. Describe the sampling distribution of the sample proportion for the samples of sizes 10, 50, and 100. So I put graphs up here. This would be like when, if I sampled 10, when n is 10, and we see something like this. When n is 50, when n is 100, what are you noticing here?
It gets better, more normal.
Yeah. Haven't we already kind of seen that before? So this is still the case that higher ends look more and more normal. So just some key points. These are true. These were true for X bars when we were talking about sample means. This is still true for p hat. Talking about the shape as n increases, the shape becomes approximately normal. When you're looking at those, the mean of the sampling distribution equals the population proportion. And then talking about the spread, the standard deviation decreases as n increases. So the bigger my sample, the smaller my standard deviation. distribution of the sample means. We said if our N was 30 or more, we could say it was approximately normal. The mean of the sample means was equal to the population mean, and the standard deviation of the sample means was what? What was sigma of x bar?
It was standard deviation.
Right, the regular standard deviation of the square root of n. So now we need to talk about how all this stuff is related when we are looking at p hat. So, this next slide, I'm going to skip this, is the sampling distribution for p hat. So this is really, really important stuff. If you look on your formula sheets under chapter 8, this is there as well. So take a quick look at your chapter 8. I just want to mention something. You only have a couple formulas here. On the left-hand side, you've got your mean and standard deviation for x bar. On the right-hand side, it's the mean and standard deviation of p hat. Remember, x bar is the sample means, p hat is our point estimate, our population proportion there. So, this is slightly different. For the x bars, we just said if we had more than 30, it was approximately normal. For this, p hat is normal if n times p times 1 minus p is greater than or equal to 10. That is not on the formula sheet, so you're going to have to know how to find that part. So we don't just have the magic number 30 in this case. We have to say n times p times 1 minus p is bigger than 10.
Is it greater than or equal to 10, or is it bigger than?
Greater than or equal to. The mean of p hat is just our population proportion, or the mean of our original population there. The standard deviation, sigma p hat, is the square root of p times 1 minus p over n. So very important things here. One other thing that we're going to have to say, in order for this to work, we need every trial to be independent. And so what the rule is, your sample has to be less than 5% of the entire population. So when we're looking at these, whatever our sample size is cannot be more than 5% of the entire population.
Wait, what's that for? Like,
Just, that's kind of another requirement here, because we need our trials to be independent, and if you take more than 5% of the population, then that's not going to be the case. So like if I were talking about Monroe City and the baseball field example, could I poll 500 people to get a point estimate? Would 500 be less than 5% of the entire population of Monroe City? No. So most of the time, we are going to be talking about very large populations, so usually that one isn't an issue, but it is something that we are going to be checking on every problem. So really, before you can start the problem, there are two criteria that have to be met. Your sample has to be less than 5% of the population, and n times p times 1 minus p has to be greater than or equal to 10. So we will start every problem with this. Any questions there? Let's do some problems. Okay. Hold on. Did I skip one? I'm going to do this one. Sorry. Okay. So back to the impeachment example. So according to a poll, 42% of voters believe the president should be impeached. Suppose we get a random sample of 50 voters and determine which voters believe the president should be impeached. Describe the sampling distribution of the sample proportion. Let me let you jot down the question first before I... The first thing you have to do always check your criteria. Okay, those are two things. Your sample has to be less than 5% of the population. Would 50 voters be less than 5% of the entire voting population? Yeah. I didn't tell you how many registered voters there are, but we can assume, even if it was exactly 5%, then you're still talking not very many people. There's definitely a much larger group than that. So we can assume that 50 is less than 5% of all registered voters. There's really not a lot to check there. You just need to tell me that it is so I know that you've looked at it. The second thing is the n times p times 1 minus p has to be greater than or equal to 10. That's what will tell me if it's normal or not. So my n is 50. What is my p? So 1 minus 0.42. Okay, so if I multiply those,
Is your n times p? The n times p, why is that just the 50?
n is 50, p is 0.42.
Okay.
And we get 12.18, which is greater than 10, so that means it is approximately normal. So those are your two criteria that you have to start. That's the first thing. Now we need to give our mean and standard deviation. So the mean for the sample proportion, the mean for p hat, is just p, which is what in this problem? The standard deviation for p hat, we wrote down our formula. It's the square root of p, so 0.42, times 1 minus p, all over n. And what was my n in this case? 50. Standard deviation of 0.0698. And that's all I asked you. Describe sampling distribution, so we did it. We confirmed that we had less than 5% of the population. It is normal. We found the mean and standard deviation. Questions there? Good enough. According to the Centers for Disease Control and Prevention, 18.8% of school-aged children ages 6 to 11 years were overweight in 2004. In a random sample of 90 school-aged children aged 6 to 11, what's the probability that at least 19% are overweight? Let me let you write the question first, and then we'll talk about it. Before we start, we have to check the criteria here. Two requirements. We are talking about 90 children. Would 90 be less than 5% of the entire population of children between 6 and 11 years old? Yeah. Okay. Second one, we need to check if it's normal. So my n is 90. P, what is the probability of being overweight?
1.18
times 1 minus p. And that gives me 13.74, which is greater than 10. so we know it is approximately normal. Okay, so we've done our criteria, now we can move on to the actual question. We need our mean and standard deviation to be able to work these problems. So the mean of p hat is going to be what? Standard deviation of p hat is the square root of p times 1 minus p over n, which was 90 children, so when I get the standard deviation 0.041185, I'm going to keep a few decimal places. So as I go throughout my problem, I can calculate that. Okay, we are finding the probability that at least 90. Okay. So what would our p hat be, our point estimate be, if it was equal to 90? How am I going to find my p hat? Oh wait, it wasn't 90, was it? I'm looking at the wrong question in my notes. It was at least 19%, so that is our p hat, 0.19. So I need the probability that my p hat at least means that much or more. So I need my proportion to be greater than or equal to 19%. So just like before, now we're back to doing all the same stuff. Change it to a z. So you do your p hat minus your mean over your standard deviation. So I get the probability that z is greater than or equal. We only need 2 decimal places, so 0.048, so 0.05. To find greater than, you do 1 minus, go to your table, back to our normal table, and we have...
I got 0.0048.
I have 0.048. Your standard deviation is 0.0.
I did 0.4. Wait, so what did you get?
0.05.
So it's just this minus 1.
Okay, so if we look in our table, to do greater than, we do 1 minus. The probability from the table is 0.5199. So subtract and we get 0.4801. So we have in our sample of 90 children, there's about a 48% chance that at least 19% of them will be overweight.
Are we even doing sentences or?
I could ask you to interpret it and it would just be writing those something. Any questions on part A? So a lot of the same stuff, except you just have to calculate your mean and standard deviation differently than if it's x bar. You just have to pay attention to what we're given in the problem. B, suppose a random sample of 90 school-age children, ages 6 to 11, results in 24 overweight.
Wait, how do you know whether it's x bar or p hat?
X bar is sample means, so it'll talk about the sample means. So what might we conclude? This time, I didn't give you a percent. Like in part A, I said 19%. So we need to find our p hat, so we will do 24 out of 90. that is 0.26667. Okay. So we are trying to decide if this is unusual or not to have 24 overweight. Let's find the probability that we would have more, greater than or equal to that. And again, I did the greater than because my mean is only 18%. So 26% is bigger than that. So let's find the probability that we are larger than 26%. So change it to a z. We still have the same mean and standard deviation from part A. So I get the probability that z is greater than or equal to 1.91.
21 minus, right?
And 1.91 gives me 0.9719. So we get 0.0281. So what can we conclude here? It's less than 5%. So this is an unusual result. What are some reasons that we could have an unusual result like that?
Bad sample, or we didn't wrong mean or something.
Right.
I didn't pick a very good mean.
So either we had poorly chose our sample, these people are biased in some way, maybe all of our children have some underlying health concern that would lead to them being overweight, or maybe the P that we're using, the 18.8%, is really not accurate, and we need to look at that. Questions on this one? I think I can do one more. Okay, so according to the National Center for Health Statistics, 15% of Americans have hearing trouble. So, in a random sample of 120 Americans, what's the probability that at most have hearing trouble? Well, this isn't this is to check to see if it's okay, so before we actually start, what do we have to do?
We want to make sure it's normal.
Right, so let's check our criteria. Okay. Can we assume that 120 is less than 5% of the entire population? Yeah. Okay, so our N is 120. P is 1 minus P. So if I multiply those, I get 15.3, which is smaller than 10. So that means, yes. I don't know why I keep writing less. Greater than 10. So we met that requirement. So that tells us it is approximately normal, and we can use our Z stuff. If it wasn't normal, we wouldn't be able to use that. Now, before I'm going to be able to use my Z's, I need my mean and standard deviation for p hat. The mean of p hat is just p, which is 0.15. Standard deviation is the square root of p times 1 minus p over, my n is 120. And so I get a standard deviation of 0.03259 96. So now, this was all just the legwork, so I can actually do part A. Part A, I want the probability that at most 12%, so that's my p hat, because I'm talking about a proportion, 12%, at most would be, that means probably the p hat is less than or equal to 0.12. So, we
Which is 1.15 over 0.325.
less than or equal to, that's what my table tells me. So if I look up negative 0.92,
0.177 or 0.178.
yeah. Part B says, suppose that a random sample of 120 Americans who regularly listen to music using headphones results in 26 having hearing trouble. What might we conclude? So, in order to use this, I need a p hat, a point estimate.
26 divided by 120.
And I get,
And I use that and I hit C.
so if I'm looking, this is higher than estimate, right? We said our p is just 15%. So if I want to know if this is unusual, let's find the probability that our point estimate is greater than or equal to this. So change it to a z. So my x minus mu over sigma. So I guess probability that z is greater than or equal to 2.05. So then reading from our table, greater than, we have to do 1 minus. Yep, because we get 0.9798. Plus 0.0102.
Oh, I didn't know.
Huh?
I have the exact opposite because I looked at the negatives. Oh no.
202. So this means it is unusual. It's very unlikely. Reason being, we were looking at people who regularly listen to music on headphones. So what do you think might be true?
Headphones cause hearing loss?
Okay, it might be true that people that regularly use the headphones have more than 15% of them with hearing loss. So if I asked you to explain why, that might be a scenario. Couple things I want to stress here. You have got to show me work on these, because how you round this p hat will actually give you a different number down here. Like if I rounded this to 0.217, I actually come out with like 0.0198. If I did 0.21667, I get something slightly different. They're close, but they're off. If I'm grading this, I have to know why you're getting the numbers you're getting, because we no longer have a set, everything's 4 decimal places, that's what it is. There's some leeway there, so I just have to know where you're getting your numbers from. So please, write out your work, show me what numbers you are using. Tomorrow is a work day, so this assignment is actually due on Monday.